This puzzle is called Triplers on a Rampage by Wildhound007. I got it from the Sudoku testing, what is it? Sudoku testing submissions channel of the CTC Discord. I say that every time and somehow that's tongue-tied. Okay. Um so let's take a look at the rules. Every row column and 3x3 box has one cell that is triple its value. Okay. I was looking at this 35 and thinking, how the heck are we doing that? Yeah, triple makes sense to me. Okay. Um They're the sets. Sorry, they are a set of the digits 1 to 9, and are neither within a king's move nor a knight's move of each other. Yeah. So what does that mean? So some of these cells will be triple their value. So let's say this is a triple 8. This would be 24. This would count for 24 instead of just counting for 8. And the king's move and knight's move part means that none of these cells, because that's within a king's move in chess, just right next to it. And knight's move is over 1 up 2 or up 1 over 2. So none of these cells could be a doubler, or sorry, a tripler. Is that a tripler? I don't know. A triple cell either. So there's going to be a decent amount of spacing between them. Um, but yeah, I assume that triple is going to, the triples work for these arrows. So if you put it on like part of the arrow, it counts for triple no matter what, and also on the thermo as well, which is going to make the thermo hard. Also, I guess one last step there, set of the digits 1 to 9. So if we found out that this was a double 5, let's say, then we couldn't use another double 5 up here. There's just one double 5 in the grid. Digits along the arrow sum to the digit in the circle. So this is just standard arrow. So if we found this was 1, 2, 3, then this would be a 6. And of course there can be, those triplers could be involved, so this could be like triple 1 plus 2 plus 3 equals 8 would also be reasonable, I think. Let me make sure that math right. 2 plus 3 is 5 plus 3 is 8. Yeah, that's correct. Let's see. Oh, in killer cages, digits add up to the number given, so this is a 34, so we're going to need a tripler in here. That's spoiler alert. And yeah, let's say this is triple 9, that's 27, then these two would have to add to 7, so these could be like a 2 and a 5. That would total up to 34. Let's see, on digits can't repeat in cages, but that doesn't matter. Oh, wait. Digits can repeat in cages in this, but it doesn't matter. Normally it's digits can't repeat, but they've changed the rules slightly so digits can't repeat. That's fine. Pretty much standard killers. And then along the thermo, digits must increase away from the bulb. So this is the bulb. So like a thermometer, as the temperature increases, the numbers increase, and the mercury or whatever goes up. So this digit was a 5. This digit would have to be greater than a 5. So 6, 7, 8, or 9. This would have to be less than a 5. And if we discovered this was an 8, this would have to be less than an 8, but still greater than the 5, and so on. Those are all pretty standard rules, except for the triplers set in. So let's get started. Oh, I'll put a link to the puzzle down in the description if you want to give it a try. The post said that this was like a 3 out of 5. I think I did see some comments saying that maybe it's like a 2 out of 5. So yeah, decide for yourself if you want to give this a try. But I'm definitely going to give this a try. That would be weird if I just ended the video right now, huh? Yeah, let's go. So how could we add up to 35? If we did, I don't think even a triple 8 would work, because triple 8 would be 24, which would make this 11. That's not going to work. So we're going to need a triple 9. We don't know it's here. I'm just doing it so it's not in that cage. So it's not in the arrow circle, so it's a little bit easier to see. But triple 9 plus 8 would be 27, plus 8 is 35. That's exactly what we need. So this is an 8, 9. And I'm just going to mark it like this. So the 9 corner pencil mark is just going to indicate that that's a 9 triple. So what other digits, or what other cells can we rule out? These, oh, actually, it's easier. What 37 also needs a tripler. And it can't have a 9 anymore. But actually, we can just rule out a number of stuff, including, it looks back over here, so this is the 8, this is the 9, and not there. Okay, so this can't be a 9. And this needs to be, let's see, 888 would be, what did I say, 24. This has to be 13. And we can't use a 9 or an 8, so that must be a 6, 7. That's pretty straightforward there. One of these is going to be, and actually it must be, of course, 38 must be a triple. Because that is a large cage. I mean, actually, we can rule out a number of things. I didn't rule out everything from the 9, so let's just do that now that we saw it. And this must be tripled as well. Huh, that's funny. That was one of my examples that would be tripled. It's always funny when your examples worked out, or at least sort of. I didn't triple this as well. I just tripled one of them, but that's fine. So this, the most we can do is 7, so that would be 7. That'd be 21. 21 would leave 17 left. Is that right? Yeah, 17, and so that must be 8, 9. So this is maximum all the way along. So that must be the case. Do we need a tripler down here? We're gonna need a tripler in here, actually. Because I forgot to mark these off. And that's a tripler. That surprises me that the first digit of the cage is a tripler. So then that's a tripler. That makes more sense at the end of the cage. Or sorry, the end of the thermo would be a tripler. And now we have all the triplers. Now we have 34 here. We can't use a 7. So what if we do 666? We'll just maximize it. That's 18. 18 would leave 16 here, which would be 7 and 9. We couldn't do 8 and 9. Yeah, so this would be 7 and 9. So this is 7, this is 9, this is 6, this is 7, and this is an 8 just by basic Sudoku. One of these is an 8. We've already tripled 8, so we can't triple it again. This is 666. These arrows are a little tough. Okay, well let's look at these. These are 1, 2, 3, 4, 5. If this was a 555, this would be 15. That would be way too large. So this can't be 555. Same with 444. Same with 333. That would be 9, and this would be 10 already. Really, I think this must be a 1. But if let's say this is a 2, then this would be 6. Then this would be 7, 8. And this would be unfillable, actually. This couldn't be 8 or 9. Yeah, so this must be a 1. Which then, surprisingly, takes 1 off of the end of this. Although, I guess this is a 888, so this is pretty large, actually. This is a 6, I've just noticed by basic Sudoku. 9, one of these is a 9. Probably on this, actually, because this is summing up to 24 in just 4 digits. Even with a triple here. Actually, if this is a 5, this is only 9. It's not that hard. I think it's not that easy either. This is 2, 3, 4, 5. That's not super helpful. I just happened to see that this couldn't be a high digit and it couldn't be a 1. These 2 digits, let's get rid of the green. I don't think I need that. These 2 digits are the same as these 2 digits, for whatever that's worth. And whatever 2 digits here are not 9 are those 2 digits. Okay, let's look at I didn't notice this. 999 is on this arrow, so let's see. This is 27, which is very large for 3 digits. If we do 222, that's 6. This would have to be added to 21. That's not possible. 333 would be 9, so this would have to add to 18. That's not possible. Okay, 444 would be 12. This would be 15. This would be an 8 or a 9. This would be a 7 or a 6. That seems to work. This is 5. That's 15. This would have to add 12. This would be a 7, 8, or 9. This would be a 3, 4, or 5. I think that works. I think that works. This couldn't be a triple 5 because that's the maximum this could be here. If this was triple 4, this would be triple 5, and triple 4 to triple. So this can't be triple 5 either, because triple 5 couldn't be partway along with the thermo when it's like this. This couldn't be a triple 4 either because that would be 12 and couldn't keep going. This can't be triple 3 either. Actually, if this was triple 3, this would be 9. This would have to be 10, 11. So this is just a 2. Okay. I think this must be, maybe this isn't 5. I was going to say it must be 5 because of this, but this also goes to 8 and 7. I don't know. Yeah, I guess this could be 3 or 4 pretty equally. Because this can't be 9 anyway. So this is at most... Okay, this could be a 9 though. But this can't be a 2. This is 2, 3, or 4. Actually, it can't be a 2. This can't be 3 because of the 2 there, of course. And then this is 6 effectively. So this is 7, 8. This is 8, 9. Yeah, but this is just an 8. This is just a 7. So this is an 8. Which puts 8 in one of those spots. So now this could be 3 to be 9 or 4 to be 12 equally, and there would be no problems that I see. This is a 7 just by basic Sudoku. We have a 7 looking over here. And then this is a 7 because of the 7 looking over. 7, 7, 7, one of these is 7, one of these is 7. Can I get a 7? One of those is a 6 and a 9 actually. This is a 6, 9 pair. Where do these go in box 4? They must not be in this row and nowhere else, so there's only 2 spots left for 6 and 9. And I've broken the puzzle. No, I haven't. I don't know why I thought I had. Like I had highlighted this cell, so for some reason I thought I couldn't fill it. Where does 1 go in this column? Well, it can't go up here because of this 1. It can't go here, here, here. That must be a 1. So this is a 3, 4, or 5. That's fine. Yeah. I like the 1, but I don't... The 3, 4, 5 doesn't help all that much. Da, 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 da. 9 must be in one of these 2 cells, which means 9 must be in one of these 2 cells. 8 must be in one of these 2 cells. Okay, let's say this is a 4. Then this must be 5. Because, of course, it couldn't be the same digit. Which means this is 12 and this is 15. These 3 would have to add to 3. That's just not possible. So this must be a 3. Now, could this be 4? We'll run into the same issue. This would have to be 1, 1, 1. So this is a 5. This is a 4. This adds to 6, correct? 15 minus 9 is 6. So this is an 8. This is a 1, 2, 3. This is 15, 23. So 4 is, 27 minus 12 is 15. That says 15. There we go. One of these is a 7. We have an 8 up here. We have a 4 down here. Based on those 4s. One of these is a 7. One of the 7s is down here. One of the 6s, I don't know why I keep saying one of the 6 is down here. There's only 1 6 in this row. Okay, well, let's think about this. So these 2 are pretty close because it's we're almost running into the same problem as over here. So this is 15, 18. This has to add up to 3. This is a 1, 2 pair then. We have a 2 looking over. This is a 1, 2. This can't be a 2. There's a 2 there, a 2 there. 4. This is 12 to 21. So this adds to 9. Without a 4, without an 8, without a 7. Means it must be 3, 6. Right, because 8s are looking upwards, so this can't be 1, 8. Can't be 2, 7 because we have 7s looking in. Could be 3, 6. Can't be 4, 5 because of the 4 in the box. Okay, that works. Okay, what about... Yeah, I guess this is the last arrow we have. I was gonna say, what about some other digit, but that's all we have. And I think we've done all the cages. And the thermos, I mean, this is just a bit of the thermo, and that kind of resolves itself when it resolves itself. We can't do much about it. This is 12, 20, 24 minus 12, so this adds up to 12. Can't have a 1 on it. So this could be 2, 5 minimum, because we couldn't have a 3 or a 4. So this is just minimum is 5, 2, which means this is at most a 5, and it can't be a 1, 2, so this is a 3, 4, 5. Does this have to have a 2 on it? Would that really matter if it... I guess one of these is a 2, so one of these is a 2. So if we could determine this one has to have a 2 on it, we would get a digit. So let's think about it a little bit. If this doesn't have a 2 on it, then it doesn't have a 2, a 1, 2, 3, 4. So this would be 5, 7, because we can't even have a 6 on here. This would be 5, 7, which is 16 plus 5 is... sorry, 12 plus 5 is 17, plus 7 is 24, and then this was have to be 0, and that's not possible. So this must have a 2, not a 2, 2. Okay, 4 must be in one of these two, which puts it in one of these two, which then we get a 4 over here, and then we have a 4 over here. So the way that that worked, this is an X-Wing. Let's just look at these colors real quick. There's an X-Wing. So once we finish the puzzle, either this will be a 4 and this is a 4, because this can't be a 4 because this 4 rules it out, or the opposite will be true. If this is not a 4, then this must be a 4, which rules out a 4 here, which puts a 4 here. So what does that mean? And you can kind of, if you draw kind of an X, can I do a line tool? Maybe this is a little not helpful. If we do a line tool here, we can kind of like draw an X, and that's where it comes from, the term X-Wing, at least I think. What it turns out is that none of these digits can be a 4. If we tried to put another 4 in here, then this can't be a 4, and this will be a 4, this can't be a 4, and this could be a 4, and we break the row. So I saw this pattern. That's how I eliminated 4 in here. Or sorry, eliminated 4, so 4 is forced into here, and then I saw that 4's paired up again like this, so 4's are up here. And 4's are over here. And actually 1's are over here, and 1's are down here. I guess we know what these 3 digits are. 4, 2, 5. 2, 2, that must be a 2. Oh, this can't be a 2, this is a 2. I don't know when I pencil marked those 2's, but that 2 was there probably when I pencil marked it. 9, so one of these is a 9. No. This probably can't be a 9, but I'm not going to look at that at this moment. In this row we need 1, 3, 4, 5. So this is a 1 or a 5. That's not super helpful. 1, 3, 4, 5. Okay, so this is a 3, 4, 5. This is a 3, 4, 5. This can't be a 3. This... Oh wait, no, we already pencil marked 4's over here. How did we get that? Because we have pencil marked 4's here. Well, this can't be a 4 anyway. So this can't be a 4. So this can't be a 4. So this must be a 4. How did I mess up my pencil marks there? I don't know. And I just took the spot of a 1, because this one looks over here, so this must be a 1. I don't remember how I got this pencil mark. I don't remember. I don't think it caused any mistakes, but if it did, we can rewind. So this is now a minimum. This can't have a 3 any longer. Sorry, it couldn't have a 3 anyway. It couldn't, no longer can have a 5. So this is minimum of 2-7. It doesn't have to have a 7, but it is minimum of 2-7. If it's not 2-7, then it's 2-9. Let's just take a look at 2-7 right now. So this is 2-7. This is 9, so this is 12, so this would be 21. And the minimum this could be is a 3, so this is, can give us some digits. This is 2-7. Minimum must be true, so this is 3-5. Sorry, this is 3, which put a 4 and a 9 here, which gives us a 6-9 like this. Because of the 9 looking over, this 2 looks back over this way. This must be a 2, this must be a 5. This is a 3-7. Neither of these can be 4 because of this 4. Which makes this 5-3-4. This is a 2. This is an 8-9 pair that's not resolved. At least as far as I see. Oh, this 2 is looking down. This can't be a 2. This is a 2. So now we have a 3 looking upward. This is a 7. This is a 3. Which looks upward again to see these two. 6 now looks over. This must be a 6, which places the 9 there. 8 there, 8 there. The corner must be a 3, and this is a 4. This must be a 6. This is a 1 or a 3 based on the row, but we have a 3 in the column, so this is a 1. Whoops. This is a 1. This can't be a 1. This can't be a 5. This is a 3 or a 4, but there's a 3 right there, so this is 4, 3. 5-3-4. Not a 4. This is a freebie. This is a 9, actually. Which puts the 9 over here. Oh, this is a freebie as well. This is a 5. This is a 6-7. This must be a 6. This must be a 7. 7-2. This is 1-5. Now we need a 1 in here. This is a 1. This is a 5. This is a 6. There we go. Yeah, that was probably definitely closer to 2 out of 5 than 3 out of 5. But I did enjoy that a lot. There was a lot of tricky stuff. Figuring out the triplers, especially the arrows, was very interesting. Figuring out like what could go on them, and yeah, figuring out the relationship here, how they actually had to have a space of 2 and not just a space of 1 between the triplers. That was really cool. Thank you, Wildhound, for that puzzle, and thank you all for watching.